Typically, when we think about HPC-related research, we often think about software. The fascinating thing about DEEP-EST is that we're actually creating something in real hardware, something tangible.
For me, what is very special about DEEP-EST is that it's a highly multidisciplinary project that is like a microcosmos of the whole HPC world in itself.
For me, the most fascinating thing about the DEEP-EST project is the multifaceted synergy it entails. When you have so many people from different sectors coming together to develop the next generation supercomputer.
Heterogeneity is there, will be in the European exascale system and will not go away in the near future. DEEP-EST decided to follow a modular approach. The MSA supercomputer integrates modules that are supercomputers by themselves based on different architectures. Clusters of general purpose processors are one example, or a cluster of GPU accelerators, which we call the booster. Heterogeneity is lifted to the module level by this means, and the benefit is the ability to integrate even more exotic architectures like quantum computers or neuromorphic devices, which are used for artificial intelligence or brain research. The key is to support the users to utilize these disaggregated capabilities.
Across Europe, we have a great amount of excellent novel technologies and HPC building blocks. However, you can compare that to a sports team where the individual excellence of the players does not create a successful team by itself. So it comes down to bringing everything together in a nearly production-like environment to ensure that beyond the individual excellence, you also have a successful interplay of all the components. And ultimately, through this, we pave the way for future European next-generation systems.
I would say that the main lesson learned in the DEEP-EST project is rather confirmation. Confirmation of the idea that when you're developing a new platform, that it's important to involve its users early on in order to achieve success. Build it and they will come is not always the best way. The strongest proof of concept for the DEEP-EST project is to apply it on real applications solving real problems and not synthetic ones. The development of the prototype is a true co-design effort involving every member of the project. This includes its 6 application partners, bringing a wide variety of applications with different requirements to the project, which makes the prototype more robust.
DEEP-EST has fully achieved all its objectives, and one can consider 3 main milestones: on the hardware, on the application, and on the software side. On the hardware side, we have deployed a 140-node prototype system that is run on near production environment and accessible both to project internal and early access users. On the application side, the application developers have made their applications more ready for exascale, for the systems to come. And on the software side, there is a full software stack allowing for application developers to employ the prototype and its architecture. This software stack will continue being developed in the DeepSea project, where more user-friendly and new features will be included. Team spirit is fundamental. Everybody feels part of the project and fights together for the full success of the whole.
What fascinates about the project is that you can see transforming ideas into reality, and that this reality will impact the European exascale system, and to be able to contribute to this big endeavor makes someone proud.